Hey guys, it's Miss Martinez, and today we're going to talk about irrational versus rational numbers. Okay, so let's go ahead and go to our table of contents. And today is the 26th, and today's topic is going to be over irrational versus rational numbers. Okay, the page number for me is going to be 7. If you took up 2 pages, maybe it's 8. If you like writing on the back, maybe it's 6. Okay, so let's go ahead and go to your next page. And our learning target for today is going to be classifying numbers within the real number system. Okay. And we're going to specifically talk about irrational versus rational numbers. Okay. So our essential question is, how is place value used to order a set of numbers? Okay. Let's have a refresher and let's talk about what irrational numbers are. So remember, those are numbers that they do not repeat and it goes on forever. So it has that ... at the end. Okay. And the very first thing that we're going to do with irrational numbers and rational numbers is we're going to classify them, and then we're going to say why they are in that classification. Okay. So let's talk about the number 4. Number 4, I know it stops and it doesn't repeat. It's just 4, so I can say that it's rational. It's part. If you specifically the most specific classification of it, it will be a counting and natural number, which is under rational numbers. Okay, let's look at the next number. Negative a half. Negative a half, I know it's the same as, I know that's the same as negative 0.5, right? So it stops. There's no repetition, but it stops. So I know it's going to be a rational number. And why? It's because it stops. It does end. Okay. The next number will be 1.034045 ... So those 3 dots there says that it's going to continue on forever. And so if it continues on forever and there's no repetition, then we can say it's irrational. Okay. We kind of have repetition with the 0, but it's not enough to say that it's going to be like that every single time. Okay. So our y is it does not repeat and it goes on forever. The next number, 1.034034. So this one goes on forever, and if you notice, it does repeat a little. And let me get my highlighter here. Okay, it repeats right here at 034, 034, 034. Okay, so this will be a rational number because it repeats 034. Okay, that's the type of repetition that I'm talking about. All right. Next number is negative 345.78965 ... So it goes on forever. Is there any repetition? Nope. So if it doesn't repeat and it goes on forever, that means it's irrational. It's an irrational number. And the last number, let's look at 5.3215. Let's see. There's no ... so I know it ends, and it just ends. So if it ends, we know it's rational, right? There's no ... so we can't say that it goes on forever like an irrational number. Okay. All right. So let's look at ordering some numbers on a number line, and we're going to order these numbers right here. Okay. So let's look. We have 1.41421. We also have 3 halves, which is the same as 1.5. I thought that was black. There we go. 1.5. We have 4.5825 ... 4.333 repeating, going on forever, and negative 0.25 and negative 8/10, which is the same as negative 0.8. Okay, so numbers like the fractions, I just put it in the calculator to see what decimal form they are. Okay, it's very easy. You just put it in the calculator. So let's go ahead and put them in a number line. So I'm going to write a number line here. Okay. So I know my range is going to go from negative 1 to about 5. Here I have my number line to 6. It's okay like that. I'm going to choose a blue color so that way I can put my numbers in there. Okay. So let's start with the first one. So 1.41421, and it goes on forever. So I know it's going to be between 1 and 2. And it's halfway, but a little bit closer to the 1 than the 2. So if I do halfway, but a little bit closer to 1, that's where I can put the 1.41421. Okay, and I'm going to circle it so I know it goes to that one. Okay, so that's done. 1.5, I know that's right in between, exactly in between 1 and 2. So I'm going to try my best to put it right in between both of them. And I'm going to put 3/2, right? Let's put 3/2. Because that's what the question is. 3/2. Okay. It's done with that. 4.5825. So let's see. 4.58. That means it's in between 4.5. Sorry. It's between 4 and 5. But it's closer to 5. Just slightly. So I'm going to do just slightly closer to 5. Right there, and then I'm going to put 4.5825. Okay, and then I looked at 8 at this place value to know that it's going to be closer to 5 than it is to 4. Okay, I'm going to circle it. Okay, so that's done. And then 4.333 repeating, that would be close to the 4.58, but it's closer to the 4 than it is to the 5. So I'm going to go ahead and put it over here. Okay, and that's 4.333 repeating, and it goes on forever. Okay. And then the next one, negative 0.25. So this is where it gets kind of tricky. The negatives kind of work backwards. So the negative 2.5, I know it's going to be between 0 and negative 1, but is it closer to 0 or closer to negative 1? So you have to think about, is 0.2, is that going to be closer to 0 or negative 1? Okay. So it is going to be closer to 0. So right here, about 1/4 away from 0, we're going to put that negative 0.25. Okay. And then the last one, negative 0.8. This 8 tells us that it's closer to 0.9, which is closer to negative 1. So right here at very, very close to negative 1, I'm going to put the negative 8 over 10. Okay. All right. So at the end of our notes, go ahead and make sure you write your summary, which is answering how is place value used to order a set of numbers. So I really liked your answers on the summaries from the last set of notes. There's no right answer. There's no wrong answer. I just want to know what do you think? How is place value used to order a set of numbers? So how does it help you? Okay. All right. And so at the end, let's go ahead and make sure we highlight what is the most important thing here. So the most important thing is making sure we know the why. Oh, that's not a highlighter. What happened? Let's see. Oh, painting. There it is. Making sure we know the why on whether it's irrational or rational, right? And again, rational is that main thing. So make sure we know that irrational numbers, they include numbers that in decimal form, they do not repeat and they go on forever. Okay. All right, so these were the set of notes for today. I hope you guys have a wonderful day. If you have any questions over the notes or assignments, please come to the 1 to 2 video call meeting. If you can't make that time, email me and then I will send you a link as fast as I can. Okay. Have a great day, and I'll see you